And good morning, afternoon, or evening, everyone. Welcome to another edition of Redis Live. On today's Streamscast, we're going to be chatting about building LLMs apps with memory. I am Brian Samboden, a senior developer advocate here at Redis. And tonight, or today, we're going to converse about the world of large language models, or LLMs. The challenges they present and the importance of memory and memory management in building efficient and effective applications. So today we're going to be joining a very good partner for Redis that's pioneering the art of bringing AI to enterprises. And that partner is Metal. And representing Metal today, we have the brains behind their groundbreaking tools and infrastructure, their CTO and co-founder, Sergio Prada. Sergio's impressive track record includes some time at Meta, as a software engineer, and of course, his current stint at Metal. Today, we also have Tyler Hutcherson, an applied AI engineer at Redis. Tyler is one of the main driving forces for AI at Redis. And Tyler will be elucidating on some of the critical aspects, like working with LLMs, the unique challenges they pose, and the nuances of memory management. Without further ado, here is Sergio.
Hello. Thanks so much for having me. I'm excited to be here. Ready for to talk a lot about LLM applications, specifically memory, and building chat using LLMs. I'm really grateful for having the opportunity to show this. It will be really excited, and I can't wait.
So Sergio, let me ask you a couple of questions before we get going. Give us a little bit of background on, what led you to basically working in AI and the technology. And I imagine, having worked at Meta, that kind of had something to do with it.
Yeah, absolutely. So I've been really interested in machine learning for many years. I'm considered a backend engineer mostly. But being in working in the backend for many years, I've always had a lot of passion for data in general, and a lot of the machine learning problems, once you move them to production, become data problems and infrastructure problems. So back when I was in a startup before, I worked on machine learning products, and it was just interesting how you had to manage a lot of these models live. And since then, I've always been interested in it. And then over the years, I kept working in infrastructure and APIs, and I heavily worked with integrations with WhatsApp when I joined Meta. And then we decided to leave to start our own company with my co-founders. And the initial product idea was using machine learning, but at that moment, the boom happened with GPT-3. And as we dove deeper and deeper, we started figuring out that a lot of the problems that we were solving for ourselves, we could solve for other developers. So we really fell in love with this idea of helping other developers build applications. And we started focusing on embeddings. And then everything just started growing. Once you start using embeddings for semantic search, you can build so many abstractions on top of that, which has led to many other things like just vector databases, which is how we really got connected with Redis in the first place, using the Redis search module with vector similarity search, chat applications, managing memory, which got us to build Motorhead afterwards, and so many more abstractions on top of that, like agents and building better retrieval systems, and yeah, that's how we basically got here.
That's pretty awesome. Yeah, I've been kind of following the space a lot too, and it looks like GPT-3 kind of was an inflection point where everybody that was building something somewhere around that area kind of pivoted a little bit and aligned themselves with that current, which seems to be a pretty smart move. So let's bring Tyler, and we can actually have a little bit of extra questions thrown in there before we get started.
Hey everyone, great to be here. Thanks for having me, guys.
Nice seeing you.
So yeah, my kind of role at Redis, I get to work with awesome partners and users in the community, and also customers of Redis as they work to build what I think is some of the most exciting technology, certainly in my lifetime. But to actually take that and kind of integrate it and build it into their enterprises, into their companies, I get to kind of be hands on keyboard and down in the weeds with them. And at the same time, I get the opportunity to do things like this, to talk with our customers, talk with users out there, and try to learn what they're doing, and share experiences kind of both directions. So yeah, it's great to be here, and I'm excited to get to dive into some code together.
All right, so if we don't have any more intro questions, why don't we just let Sergio do his thing, which is a pretty engaging demo. I watched it a couple times already, the pre-takes, so I'm excited to see it today.
Yeah, and actually, even before we jump in to the demo, I do want to get Sergio some airtime to be able to talk about the work that they're doing at Metal, and try to figure out from his words kind of what Metal is, and tell us a little bit about Motorhead too.
Oh yeah, thanks, Tom. So, like I said, we basically fell in love with this idea of helping other developers build applications, and we're still so early. There's so many unknowns. There's really, the best practices are really just empiric things that we really don't have any data to back it. So at this stage, we're really just focused on working with companies and developers to try to learn more and understand how the new techniques are growing. And what Metal really is a developer platform that focuses on three basic things: pre-processing and storage of the data. So let's say you, in order to work with an LLM, and we will go over this today, it's really important to know which data the LLM will have access to and how will that data look like. So all of this around pre-processing, analyzing documents, extracting tables, chunking that data, and we'll go over chunking a little bit more, but the basics is these models can only read so much before responding to you. So you have to selectively choose what to give to them so they provide you with the best possible answer. And at the same time, the same thing occurs when you're generating those embeddings. So when you are pre-processing the data, you want to make sure that the pieces of data that you create embeddings from are large enough to provide enough semantic value or retrievable context, as well as context for the LLM to respond to you once those chunks have been retrieved. So all of that, integrating with different data sources is also really hard. So you have, let's say, a Snowflake instance with data somewhere. You want to get it all the way to your data store, which it could be something like Redis search. And then the next thing is querying and information retrieval. This is where a lot of work has been done for many, many years, but now it's starting to blow up again because people are starting to discover that in order to build these RAG applications, these retrieval augmented generation applications, you have to provide the model with the best possible thing so it can provide the best possible answer. So finding that, giving a user query that you don't know how it would look like is really a challenge. And so a lot of work has been put into this, analyzing when you want to do like a semantic search versus a keyword search, a combination. What happens if you have data in an SQL database? How do you manage all of these different data sources? Is there and there's like layers of abstraction here. Like you can think of like, do we have a reasoning agent? something that decides which index to query. And then there's also like the post-processing phase. What happens if you query multiple data sources? Do you re-rank? Do you use some by-encoder, or you use an LLM to generate a re-rank? Or do you query another data based on the result? So there's so many things here, and we're working on building a lot of that. And finally, the last piece is observability. This is a really, really complicated topic, in my opinion, because given that LLMs are, in general, a lot of these systems are non-deterministic, it's really complicated to figure out ways of evaluating them, understanding them. Why was a response made? Where does it come from? What are the chunks that were used to generate a response? What does the distance mean? What does the semantic similarity mean? So a lot of those questions are really hard to answer. And we're building also a lot of tooling around that for simplifying those and improving the general flow of getting feedback and improving the system. And all of these are connected. If I could, I would make like a basic circle of feedback, like a feedback loop of these three, because you need the whole thing to feed itself in order to improve the product over time, whatever product you're building.
It's kind of like with ML ops and a lot of the advancements that have been made in that world over the last like 5 or 6 years. It's not that this is completely different. It's just that there's a ton more that you have to consider. And like you said, especially with the models having behavior that sometimes isn't predictable or isn't deterministic, it requires us to consider a lot more. And to vouch for each of these three categories that Metal is focusing on, I can tell you from like the last 2 meetups or talks I got to do in the last week, like in each of these columns here, there was a question, like a ton of questions, all focused around pre-processing and chunking. Like, what's the right chunking methodology? Like, everyone wants to know that, and we'll show some of that. I'm sure we'll talk more about that in depth, but that's not something that's like an easy question to answer, right? It depends on your data, it depends on what you're building. In the middle column, there's so many people asking about retrieval and like, what are the right retrieval mechanisms? Like, how do I make sure that the right sources of data are being infused at the right time, the right context is being retrieved? And how do I validate that those are the right sources to actually look at? And then that all kind of stacks up, like you're saying, with observability, where it's not just good enough that you get the IO to work, like that you get the thing to run, but also that it's generating responses that organizations are like also proud of, and there's not like a security concern here or a reputation concern, depending on where the application lives. So I think these three categories are like what you guys are building is really important.
So Sergio and Tyler, can you foresee human intervention based on the quality of the observability, so we can potentially on the fly or in a queue of, hey, this answer has been flagged by a different system that needs human intervention? And have you seen any of that in the field?
Yeah, absolutely. So I actually come from before Meta, I worked at a CRM company, and this is actually a feature that you always have to build when you're building a chat application that uses some sort of automation. You need to be able to interrupt, and that's an application level abstraction. So that interruption has to come from some other system, and a good way to do this is to analyze those responses with some sort of model, or have some heuristic to understand when either a notification has to happen, or when this chat has to be interrupted and pushed to a different queue for a human to address. I think that's absolutely necessary when you're building something for the real world use. And like a large enterprise would never just have something completely automated, especially for end users. We do see a lot of fully automated things for internal users like employees, or you're building like a chat application to understand your your pay stubs, but if you are, I don't know, an airline and you want to share information with your passengers, you always have to have a human in the loop, in my opinion.
Yeah, and to add to that, like the areas where I think a lot of investment needs to be made for companies that are looking to work with generative AI and large language models really is around generating the proper evaluation strategy that's going to require humans. It's going to require humans to develop like, hey, what is the list of like a consistent set of 20 to 50, how many ever inputs and questions, and then as we make changes to our system, can we track and analyze like these results? And again, there's some things we can do to speed that up and automate portions of that, but I think we're all afraid to like do some dirty work when it comes to generating like good input and output sets. It's kind of what we've had to do. It's been the hardest part of machine learning for the last 10-15 years. It's like creating good data sets to work with, both for training, of course, but also for evaluation, and to make sure that the new version of the thing that you've pushed doesn't actually break given the set of inputs. So I do think human in the loop is going to be a key thing, not just on the front end, but also on the back end in terms of like monitoring the quality of the model and making sure that you can intervene at a moment if it seems like it's going off track. And I know one area that you guys are also focusing on too is trying to be like ready for production, right? Like it's not just about building a demo. Everyone's great at building a demo these days. It's actually really easy now. Pretty much anyone that knows how to write any kind of code in any backend language can build some kind of a chatbot demo. We've all seen them. But can you talk a little bit about like what you guys are seeing in enterprise space, especially around getting this stuff into production?
Yeah, absolutely. So it's absolutely. So the one thing that we've noticed is that there's a lot of demos happening. Like we saw everything that happened with agents and like how it blew up, but getting that to production has been really hard. And I'm sure it will get there. But we took a different approach with Metal. We, from the start, focused on having real world use cases and valued just working with customers over anything else. So, for example, we could have started building infrastructure for agents and trying to get like these features so we could try to kind of target the tinker. And to be fair, we have a lot of developers. We have a free tier, so anyone can go to join our software, our SaaS, and just play with it with no credit card or anything. But given that we selected to work with customers at the beginning, we're kind of iterating with them. We've kept growing with them. And a lot of the production things that are important is having a good SLA. Like your latency has to be low. Your indexing pipeline cannot get rate limited. Like you cannot simply do this in a basic request response cycle. You have to be able to have versioning. You have to have high availability, which is something that we picked Redis for. You have to have queuing system, retry system, ways of generating new embedding copies for new indexes. A lot of like operational things that are really hard to build for a startup. We decided to build first, specifically to support production use cases. And we are so obsessed with performance, which is also why we picked Redis Search, right? We're not database engineers. We're not pretending to build a database. There's better people that will do that. But we have worked with Redis for 10 years. And so we are really tapped into the modules and how they work. And that's specifically what we picked it. Just to talk a little bit more about production use cases, we're always trying to simplify the use cases as much as possible as well. A lot of times people don't really understand what is possible and what is not. And to be fair, there's a lot of new capabilities and new things that you could build with LLMs. but a lot of times, a lot of people are, since they're just learning, they need to kind of like take down to earth a little bit their use cases, and we talk to customers and help them figure that out, achieve their best, kind of like tackle the highest priority problem as well. And then on the other hand, there's a lot of security concerns, right? And it's something that we are investing very heavily. So that's kind of like the other side of it. One side is making sure things work, are reproducible. All the chat applications that we build, for example, for financial services, provide specific quotes from the sources. We have special verifications for hallucinations. We have a lot of investment just making sure things are safe. And then security-wise, we're starting to work with other customers to move to an on-prem solution, to have different models. Today, we're going to use GPT 3.5 and 4, but it's important to understand that all of this can be abstracted away, and that's literally just an API call that we make. And a lot of people that are very security aware want to have their own instance or their own LLM. And now with these new open source ones, we can definitely move towards that.
Got it. Yeah, it's great to hear. And I think the surface area you guys are covering with building out your platform, and then actually like, it's one thing to build a product. It's another to build a product and then like make sure people are successful and like actually help them realize their AI strategy. I like that kind of tagline. And I think it's gonna play out really well. And if you guys are comfortable with that, I'd love to kind of highlight basically what the rest of our session is going to look like today in terms of the agenda, which is now this is where hopefully we get to dive a little bit deeper, right? And we're going to talk a little bit more precisely about some of these challenges. And then we're going to hand the reins over to Sergio, and he's going to take us into the code. We're going to actually get to see how the sausage is made. Brian, I think I'm stealing your quote. I think that's how you said it earlier today. But yeah, so this is what today's going to look like. If you're just joining now, hopefully you're ready to buckle up, as we're gonna jump in. And I made this just to really highlight that there's a ton of new language models out there. There's ones that you can find probably under your couch if you look close enough. But essentially, like there's a whole landscape of models that are proprietary, that are secret, and they're made public through some of these APIs. So we mentioned a couple of them. OpenAI, Cohere is another great one. Each of the major clouds now pretty much has their foundation model services. And so like Amazon has one with something called Bedrock, and they have like an LLM that they feed through that. Google has their Palm models. And then there's a ton of these like open source kind of models like Falcon and the NPT series, Llama 2, I think a lot of people have heard about from Meta. And then of course, like Hugging Face being a great provider of a ton of different language model options through their hub. So it's a little bit overwhelming if you're an engineer or developer or someone that's trying to take advantage of this. And there's kind of a whole spectrum of trade-offs between cost, quality, and also security. Like those tend to be like some of the three big areas, performance probably being another in terms of like latency and throughput. So there's a big landscape to consider. And what's also important to consider is that the models themselves actually just out of the box present kind of an inherent challenge to builders, to developers, which is what we know about language models being an instance of what we call foundation models, is that out of the box, they really only are aware of and kind of know the information that they've been trained on. This is true, generally speaking, of the machine learning and AI field. A lot of people, I think, are afraid of like the next Terminator. Things like that are probably, only a year out, I would say. We still have maybe another year until Terminator's here, but no, I'm kidding. For real though, like these models are general purpose. They're pretty good at a wide array of tasks. But they actually don't know really anything about like your data. They shouldn't, right? Like they don't know anything about your proprietary documents, your like customers, your patients, your users in your system. They don't know anything about that. They might know, again, general knowledge to be able to understand situations or to be able to understand scenarios or concepts, but they don't know like that Larry bought that fridge and that fridge broke and he's having trouble fixing it. But large language models don't know that information out of the box. The other thing is that they're stateless. And so this is a loaded term, and we're going to get into this more, but by default, like these language models don't just like remember the last things you've talked about. So your conversation you're having with them, like it can respond to your inputs, but it doesn't remember that 5 seconds ago you were just asking about something different. So maybe you're changing conversations, or you want it to be able to remember that the last time I was talking to you, this customer support bot, we were chatting about how my fridge is broken. Maybe if it was able to remember that, you'd have a more delightful experience as a user, as an end user. And you might be more likely to stick around and actually work with that particular company and continue to buy their products. So the stateless nature of LLMs actually has a big impact on their performance and like their perception. And then lastly, on a little bit more of a technical side, they have what we call limited context length or window size. And so the way you invoke an LLM is you write a prompt, and a prompt is just a string. It's a string that has some length, that has a number of tokens or words that are part of it. This is what you feed to a model, and then it sends you something back that's supposed to make sense. Well, one very important technical limitation is that these models all have what's called this like fixed window size. And so you can't actually send it infinite data. You can only send data that's like of the right size or less, which means that the data that you send it in the prompt, the information you give it at runtime, needs to be important. It needs to like be only the most relevant and most important things for the conversation. And so this presents another challenge. And I'm hoping that through today's session, you'll get to see how not only can we understand each of these problems even more, but we can actually like see how you can solve them. You can build processes and tools and use tools like Redis and the work Metal is doing with Motorhead, and you can actually build chatbots that burst through a lot of these potential issues. So, without further ado, should we get into it?
I say go for it.
Let's do it.
Let's do it. This is a link to GitHub. It's also probably maybe going to flash up on the screen here in a little bit, but this is going to be a link that Sergio is going to get to work with. And with that, I'm actually going to stop. We're going to move my screen away, and it's going to be all Sergio.
Okay. So let's see. We're going to start from scratch. The only two things I have here is just the git ignore, right? Which with the .env. And then here's where I have some API keys. But that's pretty much it. You can follow along with the repo if you want to go to the first commit. This is a completely new repo. I decided to make a new one, but we're going to follow basically the same steps. So the first thing that we're going to do is we're going to clone this repo right here, which is a chatbot. This is an open source chatbot that we built. We use it as a template for a lot of our customers. Think of it just like a ChatGPT style interface, but we added some additional features like fetching context when necessary. It just has a simple UI that we can deploy, and in general, it's just very easy to use. So let's clone this. Okay, so I can do git clone this thing. Okay, so now I have this chatbot here. I can cd into it. And if we check it out, it's just the Next.js app. Very simple. And it has this this. Let me see, verify that this size is correct. Yeah, this is good. So yeah, it has this just this single page that is a chat, and it talks to an API. And then that API basically uses OpenAI's API key, which we will have to provide just to have a basic conversation, right? So the first thing I'm going to do is I'm going to copy the .env to chatbot .env.local, I think. I think so. Let's see. Yeah, there it is. Okay. Next thing I'm going to do, I'm going to go here to the chatbot and run npm install. So this is installing all the dependencies. And the first thing I want to do is just run the basic chatbot with anything else, just to show you what it looks like. Okay, so running localhost. Let's open that in a new tab. Let me check. Okay. So if we check this tab here, can increase it in size. I can basically ask any question. Who is King Gizzard? The lizard wizard. Let's see. Awesome. So yeah, like a basic chat application, I can have a conversation with it. King Gizzard and the Lizard Wizard is an Australian rock band. That's great. Now I can ask, who is Ozzy? Right. We've all seen all of this. Just a basic chat conversation back and forth, and it looks great, right? This is very simple. Now I want to show you what happens if I refresh this page, right? We don't have any state right here. So if I refresh this page, all the history will be gone, right? We're not storing this anywhere. If I asked, what was the last question? What was the last thing I said? It's not going to know, right? Because it doesn't have access to any of that data. Okay, so let's go back to the code, and I'm going to maximize this. And the first thing I'm going to do is I'm going to bring Motorhead in. So I'm going to create a Docker Compose file. Compose.yaml. Cool. And it should be like version 3.7. And we can say services. This would be Motorhead. And so this is a great introduction to what is Motorhead. Motorhead is an open source project we've been working on for quite some time. And I can show it here. So what is Motorhead? And I can start talking about it for a bit now, how it started. Motorhead is an open source project. The idea is that when you're having these chat conversations, you can only fit so much to the context window, which is something that Tyler was mentioning. You can't simply always include all the chat history, right? Because you can only have so many tokens, so you will basically have an error. But then on the other hand, if you don't include all the chat history, the bot won't know what you're talking about all the time, right? It's going to be really hard to keep up with everything that you have talked to with the bot about, and so Motorhead was created in order to allow developers to build applications, chat applications, and manage the memory in a very easy way. It's a server, it's built in Rust, and it uses Redis as the main data store. And I'll go into detail why in a bit, but it just provides very simple APIs. I think it's just 3 APIs. Oh, 4. Get sessions, get memories by session ID, which basically just returns a list of messages. An API to create those memories, so create those messages and push them into that list, and we'll show how that works in detail in a bit. Finally, deleting it, deleting all a session itself or the memory, and then the last thing is the retrieval, which will be the last thing we'll talk about.
Awesome. Hey, Sergio, I wanted to just make you aware that we have an interesting question from someone as we're about to add Motorhead to the app. And I was actually going to ask you this too. It's just like the basic chatbot that we have there. Can you clarify like how many LLM calls are being made for a given query, along with similarity results, which may be something you want to touch on, I'm not sure, to get the answer. And that might be something just to help clarify for everyone listening.
So yeah, I can show you exactly what the code is doing here. So normally how a RUG, so there's a lot of ways of solving that. In this specific example, what this chat is doing is we are, so the first thing I have to note is that this chatbot here is built for using Metal, which will provide the context. But given that we don't have any indexes, we're not retrieving any data from Metal. This is literally just using the last message without any additional context. So to answer your question, a regular RAG application, you receive the user message, you generate an embedding from that, and I wouldn't count that as an LLM call, because that could be like any model, could be like a sentence transformer or just an OpenAI ADA too. You generate that embedding, then you use that embedding to find similar things, right? And that's where the vector similarity search starts into play. You get back those records, and then with those records, you include, and this is what we do here, you include that as a context. So this is kind of like the prompt. You include that context, which is the result from retrieving that data, and then the message that the user made or you did, and then you ask for the answer. And so in that way, it's just a single call to an LLM in this case. But that being said, I've seen a lot of cases where this can get really more complicated, where use cases where, for example, you need to do re-ranking of some data before fitting it to the chat application. So an example is, let's say you have multiple places you have to fetch data from. So you fetch all of that data, and now that you have all of those results, you want to, before feeding that to chat, you want to first make a list of the top 10 results. So you can give everything to an LLM, given the top 10 results, given this query, what is the most valuable, what are the top 10 most valuable things I can get from this, and then use that for a chat. So you can abstract these things as much as you need to, but generally speaking, it's normally a single call.
Got it. No, that's helpful. And again, just to reframe it, it's like the first thing Sergio showed us. Maybe you can pull up the chat interface again, just for showing it, for especially for folks who are just here. But this is really just the simple kind of like hello world, I guess we could call it. chatbot, where there's not some like corpus of knowledge here that we're working with. There's also not any kind of like state that we're introducing in the form of memory yet. And so that's now where Motorhead comes in.
Exactly. And one last thing I wanted to mention, this is a perfect use case for in a lot of cases. If you think about some sort of chat application that doesn't require, like, let's say you want to build an application to chat with your docs, right? With your developer documentation or with your knowledge base. You are an airline and you want to build just a basic chatbot to have sort of like a first line of defense before getting to humans. You can do a stateless bot, right? It's not always necessary to have memory. That's really useful when identity is really important. When I, as Sergio, talking to a bot is different than you, Tyler, talking to a bot. But again, when you're talking with developer documentation, knowledge bases, Wikipedia, identity is really not important and history is not important.
Makes sense.
Okay. So, yeah, so this chatbot is completely stateless. I refresh this and it's gone. So the first thing I wanted to do is just basically bring Motorhead into this. And what I was saying is we built Motorhead open source. You can try it out today. It's very simple to use and set up. It only has that dependency of Redis in Redis server stack. I think it's called, stack server, sorry. Which is where the Redis search module is. So if you want to have long-term memory, you will need that. And I can start hinting a little bit where we're going from this. This chat history, as I was showing it, like having everything that is within the context window, everything that that the LLM can have access to, is kind of the chat history is kind of called short-term memory for some reason. It's kind of like a metaphor for when you're having a conversation with a human and you remember all the back and forth you're discussing with that person. But then if you ask that person something about what they had for breakfast yesterday, they might have to stop and think, like, I don't have that right here in my brain. So I have to think a little bit, okay, I had a bagel for breakfast yesterday. And so kind of like that metaphor of thinking a little bit longer to try to access that memory is the long-term memory, which is where we use embeddings and vector similarity search. So that, I think that's where the term comes from, but I'm not 100% sure. But yeah, this is basically a way to enable that. And I'm gonna copy this. Okay. So here I can copy the Docker image of Motorhead. And so I can bring Motorhead here. I can say image equals this. And I can expose the ports. Let's do.
Hey, Sergio, I have a quick question. What other ways to acquire a running copy of Motorhead are there besides the Docker image?
Yeah. So, I mean, I think Docker image might be the easiest way to do it, but you can also just clone this and compile it yourself. Here we have the Docker file here if you want to check out and see how we're building it. Or you can also just generate the binary yourself. The one the one thing that we do need is we need to inject these environmental variables in order to really, sorry, let me just show them here. These environmental variables in order to really allow the model to excel. So for example, the max window size, and I can talk about this now. The max window size is kind of like the maximum number of messages that a session can have before we run a reduction or incremental summary. The long-term memory, which is basically a flag to enable vector similarity search for all messages. And this will basically create every message that you create, we will generate an embedding and push it to a vector index. And that way we can expose it through a retrieval endpoint. The model that you use, right now we're just using OpenAI, which is the simplest one, but we can easily switch it up with something else if you need to. The port, of course, as this is a server that is running, the OpenAI key, and finally the Redis URL. So in this Docker, we're running Redis here, and we're going to do the same thing. Actually, I'm going to copy this. But if you have your Redis instance running somewhere in the internet, you can just simply provide the URL and we'll connect to it. Does that answer your question?
Yes, thank you.
Okay. Yeah, so let's just add here whatever we need. I'm going to copy these over. It's going to be faster. Okay, so if we go over this again really quickly, we have the Motorhead image, the ports where the server will be running. We want to index every message into the vector index, the port, and the Redis URL, which we just use Docker Compose networking to connect these two. Okay, so now we have kind of like the backend, right? And we can actually go here, create a new terminal, and we can say, actually, we need to cd into Motorhead Redis. Yeah, cool. So now I can say Docker Compose up. There's the typo. Let's see, services. What was the error? There's my services, Motorhead, additional provident environment. Okay, that's a typo, I think. Yeah. Okay, so if we go here, it basically created two containers, the Redis container and the Motorhead container. This is Redis starting up, kind of like the Docker noise that we can always see from all of these services. And yeah, so the server here started, right? And so what can I do? I can go here and I can curl localhost 8080. Let's try this first. Yeah, okay, so that's the kind of like the health check. I can say sessions 666 and I can say memory. Cool, so this is basically like an empty response, right? No messages, nothing for that session. I can do that kind of like for any session. And it's kind of like the empty response of the server. So let's go back here and let's start adding that to the chat application. So the first thing I'm going to do is I'm going to remove this. I'm going to comment this out, which is the retrieve context that is normally used with Metal. And I'm going to comment this out as well. This is how we do kind of like the RAG. We fetch the context and we inject it to the last message. And here, instead of doing this, I'm going to do last. That's it. So basically, pop is a way of getting the last message in an array, and then we're basically re-including that message into this array. That's it. And then here we just are doing the rest of the prompting, which is not really that important for this demo. But I want to just, I just want to show how we can connect Motorhead to this. So if I refresh this and we can retest it, what is this King Gizzard? Okay, so King Gizzard is the lizard wizard, blah, blah, blah. That works. Now, if I refresh this, it's gonna be gone. So let's work on that right now. Let's start adding some state. So if I go to source index, I think. Let's see. So pages, index. Okay, so the first thing I want to do in order to showcase how we can manage multiple sessions is I want to add a query string here. Yeah, and here in my Git, in my history, you can see. So I want to be able to add like a query string to just manage, just kind of like simulate how different user sessions would look like. And so that way I can jump across different sessions and each session has its own history instead of just having like a single user demo because it's too boring. So let's do import use router. I think this is from Next. Is it router? Let's see. Yeah, router. Okay, and now what we can do, let's say const router equals use router. Okay, so this is a hook to basically access this the router data, and we can say like const session equals router dot, I think it's query. Okay, so now we have access to this variable right here. So what is the next thing, right? The next thing is we need to send to the backend these messages, right? So how these Next.js applications kind of work is these API folders where we can write endpoints, and that's where kind of like the backend of the front end is running. It's a little bit confusing, but what those endpoints allows us to do is to talk to Motorhead, to send it data. And so that way we can control it better. And so we need to do that. So the first thing I'm going to do in this use chat here is I'm going to add the session, which is what we just got here. And the other thing is we need to add a hook here. So on finish, actually have here. And finish. We're going to run this function. So this, by the way, this use chat is how we are showing the messages, how we're interacting with the LLM in the front end, and that basically connects to this file right here where we were commenting out the retrieval pipeline and making the query to the LLM. So this hook will allow us to make an API call whenever this is done. So whenever this, meaning the message that was sent, is done. So I can say a role And now what we need to do here is we can say const message is equals content row. And now what we need to do is we need to write to the API that message that we just created. So we can say API messages, and then we need to be able to provide the session ID. That way we know in Motorhead which session we're talking about. So in this demo, we can do session equals session, but there might be better ways of designing this API. We're just doing this in order to go faster. Yeah, so we can say a fetch method post. And then the body is going to be that's those messages. So JSON, stringify messages. Okay, let's see if this renders. Yeah, this renders. Sounds good. So now we need to write this endpoint because right now it doesn't exist. So let's create a new file. And this is going to be messages TS. So this API is going to get called whenever we create a new message, right? So I'm going to copy this code here and adapt it just to go a little bit faster. Okay, so data will be any. We're just going to skip the types for now. Okay, so the handler is here. Let's see, what is this? A string, JSON parse rec.body. Okay. So the first thing that we need to get is the session, which is being sent here in the query string. So it would be rec.query. So now we need to get the body. So instead of doing this, we can say messages. Actually, do we need to? We might not need to do this, but we can remove this. This is from, yeah, we don't need this. And we don't need this. This was all copied. We can keep the response. And I'm just going to maximize this to make it easier. Okay, so we got this thing here. We have the message, and now I can comment this. I can console the log here, the session if we need to. So what do we need to do here? First, we need to check if the request method equals post, which is the API call that we're making here. And so if it's post, we want to await fetch, and we want to send this to Motorhead, right? And for now, we know it's in localhost 8080, and the endpoint we know it's sessions, then session, and then memory. And what we want to send is, this is going to be a post. We want to send the body that we received. So rec.body. And finally, we should specify the headers. So this would be content type, application, JSON. Okay, this should work. So yeah, we don't need to parse the body because we already know we're getting the messages here. Obviously, ideally, we would have some sort of validation, but for this demo, this should work. And then I'm going to get a little bit ahead of myself here, and we're going to say if it's not a post, then we're going to get the messages. No body, some headers, and then we can say Motorhead response equals await this. And then what we could do here is we could say const messages equals await Motorhead response.json. So here we are fetching the messages. By the way, this should be backticks. So we have the liquid variable. This as well. Okay, so we have the messages. Now let's remove this and return this here. We can do this, and now we need to return here as well. We can just do this for now. There's no index, so we can say just data would be empty. This index doesn't exist. This was because we copied it from the other file. So here, messages, I think that's it. Will this work? Let's see. So I'm gonna turn it off, turn it on again. Let's run it. Okay, looks like it compiles. So what happens if I go here? First, let's do this. No, let's maximize here. I'm gonna open here, network tab, and ask again, who is King Gizzard? Let's see if that works. Okay, now when this is done, we should make a request. Let's see. It's running. Okay, here, that's the request made from that hook on finish. We call this endpoint, which we called this post, which basically calls the localhost 8080. That means that Motorhead should have gotten a post. And here you can see it, post. Session 666 memory 200. Awesome. So, okay, we're starting to store some data. So let's look at that data. So here I have Redis Insights v2. And this is a really cool GUI to explore. Redis CLI is also great, but this is really cool to explore like what is going on, kind of like a macro level, easier to read. So let's check it out. We have sessions, and there's this list session 666. So let's click on it, and oh, looks like it has a list of messages. Wait, but it only has the assistant message. So we're missing the user messages. So what happens if I refresh? Oh, there's a 404. Okay, let's figure out what is going on. So when we load, we're going to, okay, so right now we're writing the messages from the LLM, but we're missing two things. We're missing writing the messages from the user to that, to Motorhead. And then lastly, we're missing the loading of the messages. And that's where we created this endpoint, right? So in order to load, we just simply have to, in the UI, add an infamous use effect. So we can do use effect. And the first thing that I always do is just add if, otherwise this thing might run forever. So if session return. And we also need to add a dependency here in order to make sure that this doesn't run in an infinite loop. And now we can say fetch, basically this, right? This would be like, this would be a method get, which actually we don't need to add this, but I'll keep it. And we can do .den. So this is a promise. Let's add this async here, rest. Okay. Say const JSON would be rest JSON. So we receive the response, we parse the JSON, and now we need to get the messages. So we can say JSON data and then messages, and we can do a new, we can do this. Now we need to set the messages. So let's see if there's state for that. Set messages. Yeah, here it is. Okay. So now we can do just set messages. Cool. So now we're loading the state. If we refresh this, what's going to happen? Okay, so we did do a get, but we're not loading it. So we'll look into that. Here's the response messages data. What we could do here is just log the messages. Oh, empty. Interesting. So JSON data empty. Let's log this. It's the wonders of working with JavaScript as well. Okay, JSON data. What is JSON? It's a promise. We need to wait. Okay, that's probably the bug. Yep. Oh. Okay, so that worked. The first thing that I can tell you is I wasn't awaiting this, so that therefore it wasn't working. The second thing is we're only loading the assistant messages, right? Which matches with what we're seeing in Redis. And that's because we're not writing the user messages, so we need to add that. And in order to do that, whenever a user message is sent, we're calling this chat endpoint. So this handler receives here a bunch of data, and then here's where we make the prompt. So what we need to do here is we need to also call the LLM with that last message. Sorry, call the Motorhead, right? So for that, we can say await, fetch. What we're gonna do, basically copy this thing. And the rect.body is going to be JSON stringify messages, I think. And then this would be role user. Actually, I think it's just last. I think it's just this. So now where is session coming from? It would come from here. So if we go back to index and we look at, yeah, we included here in the body. So this is included in the request. So I can destructure it here, and now I can include it there. Okay, so let's try this again. Make sure everything is rendering. Yes. Okay, so I reload this. Let's go to another, or let's keep it here. So what is, or who is the best metal vocalist? Okay, so how this thing works. Should have gotten another post. Yeah, there it is. And then we're going to get another post. Yeah, there it is. Okay. So the one thing I want to check is what happens if I reload this. It should come back exactly the same. Awesome. It does. Cool. So what happens if I change a session? It's gone, right? Because now we're hitting a different endpoint. And if I go back, cool. We have state. So that's cool. And now let's check Redis what's happening. So if I reload this, to reload this. Okay. So go to sessions key. Okay, now I see the 3 messages. Oh, there's actually another bug that I just noticed. If you notice this, the sort of the messages is wrong. So we can fix that really quickly here by just saying inverted equals messages reverse, I think. And then we can just send this. Let's see if this works. Yes, now it works. Cool. So let's go back to this Redis Insights. So we can see here we're creating pushing them to a list. Each session has a list. Now, if I actually create another session, I want to see 2 sessions separately. Here is, we can say, who is staying?
Hey, Sergio, quick question. Can you control the length of that short-term memory? Know how many messages can be kept in that session?
Yes, we can. Yes, we can. We can control it using an environmental variable in Motorhead. This Motorhead max window size, which defaults to 12. And I can show you what that looks like when we reach that threshold.
Excellent, thank you.
I want to show you how it looks like with Redis running monitor. So here I am in another window. Oh, by the way, here I can fetch, right? We're exposing Motorhead to localhost, so I can fetch it from here. And here I had a typo, so the assistant was correcting me. But I can do Redis CLI here. And here I can do monitor. And I want to have this window here for, this command is really cool if you haven't checked it out. It just provides like a good way to debug stuff and see what's happening in Redis. Okay, so if we reload this, oh, here, reload. Now we see 2 keys, right? So you're starting to see that we kind of keep that data separated. I can have this in a new window as well. And it will just keep both states separated. And so the question is, okay, so cool, we have state. Now, what's the next thing? The next thing is pushing messages to this and reaching that window size. So let's do that. And the first thing I want to do before that is I want to make sure that we have long-term memory enabled. That is true. So if I go to Redis search, there's an index, so I can select it. Okay, so that is basically pushing that config is pushing to this Redis search index every message. And right now we're not using this, right? But I wanted to share this because we will be using it. So you could see we have a vector and just some basic data, including the content, which is really important for our augmentation part of the RAG application that we'll do later. So I'm going to do something interesting here and I'm going to say my favorite band is It's a hard one, but I think it's going to be, let's just say Motorhead. And I'm going to purposefully add this message here because this message is going to be deleted from the short-term memory. And later down the line, I'm going to ask something about this. I hope it works. We'll see. But okay, let's keep talking. And I'm going to completely change the subject. Let's say, where's Colombia located? Right now, I'm just going to spam this bot with Colombian questions. What is the capital of Colombia? Awesome. Where? Let's see how many messages do we have. One. Actually, we can just check here. So let's go back to the Redis part. Sessions, keys. Session. Okay, so we got 9. What? Okay. Oh, let's do like a quick refresh, make sure that all the state is getting loaded correctly. It looks like it. And so here, let's say, what can I eat there? In the meantime, let's refresh this. Okay, so we got 9. What can I eat there? And then we probably got a 10th, sorry, an 11th. Okay. This is a log that we added. Actually, I'm gonna make this bigger because I want to show what's happening here. Okay, so what can we eat? A bunch of stuff. All of that is delicious. I highly recommend it. And now I can say, what are many rivers are there in Colombia? Okay. So we created the message from the user. Now we're going to create the message from the LLM and check this line, running compact. So what is that? That happens when we reach the threshold. We reach the threshold for the 12 messages or the max window size. And so I'm going to refresh this and I want you to check out what happens if something happens. I hope so. Let's see. Yeah. So we had 12 and now we have 6. And if you check out the messages that we have now, they don't contain any of that metal nonsense that we were talking about, right? So, well, no. Let's check out the context. If we check the context here, this is kind of a summary. The human asks about King Gizzard and the Lizard Wizard, and the AI provides a description about the band and its members. The human then asks about the best metal vocalist. The human then mentions their favorite band, Motorhead. And then we're going to keep going, keep going, keep going. Okay, so what happened here, right? This is the compaction that is running in Motorhead. And this is just a basic function. If we go here to reducer, we're essentially running sort of like a map reduce or an incremental summarization of the messages. So as the window keeps growing, when it reaches that threshold, we take the older half and we summarize that. And then we combine that summary with the previous summary that existed. Since in this case, there was no other previous summary, then we just created that one from those 6 messages and that's it. But let's say we keep talking, we keep chatting.
Sergio, a couple of questions before you continue. Somebody was asking about the LLM being used, and I believe it's GPT 3.5, correct?
Correct. Yeah.
And also my own personal question here, for the summarization, is there any kind of semantic math being done to summarize things that are alike? or this is like a round robin summarization? And what model do you use for the summarization?
What do you mean about the semantic mapping? Can you explain
Well,
that?
I was thinking this might be actually a feature request. Let's say that you have a context that maps to a specific, area of your, domain space of content that you have for the conversation, and then another one maps to a different area. For example, you have a metal in Colombia. If more data about metal keeps on coming in and more data about Colombia keep on coming in, it's likely that they're going to basically cluster in those two areas. Would it make sense to basically then summarize the cluster individually rather than mix them together?
Yeah, that's an interesting question. I think it's like a very specific thing. So one thing we could do, which I'm not sure we're doing today, is expose that prompt that is being used for the summaries. And you can definitely do that with a prompt.
Nice.
So yeah, I don't remember out of the top of my head if we do expose it. My gut feeling is we don't, but we should. And now going back to your other question, the model that is being used, GPT 3.5 all across, just because it's so simple to use. Yes, that was the question I was answering. And yeah, does that make sense?
Yes. Yeah. Thank you.
Awesome. So yeah, so basically we are gonna keep chatting with this bot. And by the way, since we are using as a state this list right here that just got reduced, 12 is a small number. And this is like 6 messages isn't really a lot. So if I reload this, it's only going to have the last 6, right? Because we're using that. But this could be way larger. Just for context, it's like it really depends on your use case. And you will always need to be able to handle context window problems effectively. So this isn't like a silver bullet. You will still need to work out when to trim, when to summarize in other parts of the stack. But where I was going is, okay, we have access to this context. So what happens if I asked, what is my favorite band? And if you recall, it is Motorhead for this demo. But I don't think this knows. Yeah. Right? Because if you think about what data this bot has, it only has access to this last 6 messages. It doesn't have access to the context, which is this summary, because I haven't added that to it. And it doesn't have retrieval. And instead of adding the context, I want to jump straight to retrieval. That's just because it's going to show, it's basically a very similar concept of just getting data from somewhere and injecting it into the prompt. And just retrieval is more flexible in general. So what we're going to do is we're going to copy this metal retrieval and create a new one, which is going to be Motorhead. And what we're going to do here is we're going to say localhost 8080. And now this would be sessions. This would be for a specific session, and then retrieval. We don't need a limit or anything else. And this would be motor results. Okay. Now what we're going to add is we're just going to send some text. That's it. We don't need this. And we need to pass the text, and we need to pass the session here, which is also going to be text. We don't need limit. And then the results will be here. Awesome. So we have this function here that we'll use to retrieve context. So now if we go back to the API chat, remember what we commented out here? So I'm gonna uncomment this, do this, then remove this, or just comment it out. And now retrieve context, and it would be the text and the session, right? And in here, instead of metal, we're going to say Motorhead. Okay, so retrieve context. Okay, yeah, let's try this out and see if this works. So let's see if it rendered, if it compiled or transpiled. Yeah, it looks good. So now I'm going to refresh this, and I'm going to ask the same question. And I want to see if I'm not even going to debug it. I'm going to completely trust, but I'm not sure if this is going to work. Yeah, failed to fetch. Okay, perfect. So let's see what happened here. Generator failed to fetch. Great error message. 404 not found. Try again. Okay. Oh, look. Okay, so we got an error from Motorhead. Request parser invalid header provided. Okay, let's see what header we're giving here. Actually, let's figure out what's going on. So we got headers here. Okay. And let's verify the endpoint in Motorhead. Let's see. So, oh, HTTPS. Okay. Localhost 8080 session, and retrieval. Yeah, the rest looks good. Okay, maybe that was it. Let's try it out. I refresh. Okay. So it doesn't know my favorite band. Let's copy this. Let's ask again. It doesn't know. It doesn't know. So let's log the context here and now start debugging, just making sure that we have access to that data. Let's see, retrieve context. And response question, yeah, this should work. Let's see what happens. So let's ask anything else. Who is Dave? And let's look at the logs. Okay, undefined. Awesome. So now we know something's going wrong here. Okay, so I see. I think the results here are different structure than metal. So let's log this here and just keep returning that. Doesn't matter. Let's just do the bug. Definition. Console.log. Okay, undefined. Awesome. Let's see. This is undefined. Okay, so no data. Okay, let's do this. If we actually check here in Retrieval, let's check out and see the structure of the data. Okay, results JSON. Okay. So results would be the response of this. Okay. So search messages, was that defined? The long-term memory, search messages. Okay. Oh, actually, this is cool because I can show you how we're running the search in Rust in the Motorhead piece. So we receive a query and a session ID, as well as the OpenAI client and the Redis connection. We generate the embedding, right? And that's in order to run that vector similarity search. And then we have to encode the embedding, which is necessary for Redis. We generate the query. So here we are saying for the session ID. So this is kind of like a hybrid search. We run a KNN, get the top 10 results, and the vector will be the V parameter. So V, the vector, which is the encoded embedding, and then we want to return the distance as well here. Yeah, and here we say sort by distance. Awesome. Okay. And now the results, and then we have to parse the results. So let's see, parse results, B models parse for this result. Strict distribution. Okay, so I think we're just returning the raw results. So the raw array. So that means I can say Motorhead results that map, and then it's just, but this will probably return the objects. So what we're going to do here is we're going to return that role and content. And then we're going to join. Okay, let's try this again. So if I load this and save Mustang. Awesome. Now you can see here the context. It's way more rich. Okay, so now I think it will be able to tell what is my favorite band. So let's ask, what is my favorite band? There you go. Yeah, that's good. So now it remembers everything we've talked about, even beyond that window. And yeah, I think that's pretty much it.
That is pretty awesome. Hey, do we have a question about the data sets or the different data types that you're holding in Redis?
Yeah, absolutely. So we are using we're using lists to manage sort of like those messages, and we use it because it's very simple to get to trim and to get a slice. And since these lists are always going to be growing and getting trimmed and growing and getting trimmed, and we need to have that for end users. It's really, really easy and scales really well, fast. like if you think of how how you would do that in a database, it would be like a regular SQL database. It would be like more tricky. You could still do it, but I just feel like the flexibility in that list is in Redis is so much better for this specific use case. Additionally, like I said, we have all of these hashes, which are representations of each message. And these hashes are essentially what live in the index. So Redis search, you create an index, which is basically, think of it like a pattern of, you can use it, like how I understand it with hashes is you use a prefix, and every hash that matches that prefix is going to get indexed in this data structure. And so when you query that index, it will basically return any of these hashes. And yeah, so we use Redis search with hashes. We use vector search. So we provide that vector for the KNN, which is what I showed you. And if I actually share here, what did we search in this session? Oh, but we asked something very similar. But what I wanted to share is that the search that is happening in Retrieval is specifically for that user 666 and no one else. So that means that you can run these filter searches, or if you abstract that even more, you can do multi-tenant indexes as well. And the other thing I wanted to share here is the distance. The distance is basically this is the cosine distance between the two vectors, the one that I provided and the one that is in the index. And that is a way of determining how similar things are for those who are not familiar. And so here it returned, I asked, what is my favorite band? So it returned these two. First, there's probably a difference, like, for example, there's a space in the first one. The second one, there isn't. So there's very mild differences. And then it says Motorhead. Let's see, my favorite band is Motorhead, right? So that's how it kind of like relates questions to answers. And you can extrapolate this example to any other thing. Yeah.
So Sergio, can you talk a little bit about the similarity happening on the prompts, but also on the results? The similarity searching?
Yes, of course. So here, when we receive the user message, we say, okay, let's retrieve that context. So we take the message that the user just made, get the content, which is the basic text, and we run for that session of retrieval because it could contain information that is in those past messages. And now this hits Motorhead. And I actually want to show again this part because I think it's really cool. So it hits this endpoint, right? And here we run this search messages where we filter by that session, we get the top 10 results, and we sort by the distance, which is how similar those two things are. And then we return back to the client. And in the client, here this is where I log the context. So we have this very long console log here. But what we do here is we basically modify the last message. So instead of sending the existing content that we say, like right now here, this looks like, what is my favorite band, right? And now here we modify. We say, okay, so the response to the question will be everything that wasn't last. So right now it's still like this, but then we modify the content to include that context. So now we're basically saying something like context, my favorite band is Motorhead, and then question, what is my favorite band? You know, that's kind of how it works. Obviously, it's not that specific, but because in the context you add so much more. But ideally, if you make this type of question to an LLM, the probability of it being right is very, very high. And so that's why these applications have been exploding, because it's a really good way of getting very positive results. And we didn't have to do any fine tuning or anything like that.
That's pretty impressive.
And I have one interesting follow-up question too on that. When you're doing the search over your historical, your chat history, essentially, like we're looking to find relevant messages that the language model will need to help answer your query. Are you searching over the entire indexed session, or are you searching over just the user messages, or like just the assistant responses, like, or is it both of them? And how do you try to assemble those in a like logical way, when you're working with them?
Yeah, absolutely. So I can show how the index gets created here. This happens like once on startup.
Mhm.
And then what we do is if there's an error, we just handle the error. If the index already exists, for example, an error will be thrown, and we'll say like, okay, the index exists. Let's start the server. So I want to show you this just to explain a little bit the thinking here. So first is that I forgot the word. The prefix. So every hash that matches that prefix will be indexed automatically here. So that's the prefix, right? Motorhead, colon. And then we define the schema. And here's where we kind of like the schema that we can use to then filter down the index and get better results. So right now we don't really use anything else besides the session to really get to really filter down the results. So we only use the session to filter down the results right now. But you could definitely expose that to a user or to the API, or just have a preference, right? Maybe I only want to search through my questions, maybe only through the responses. That's kind of like an open question right now. Unfortunately, we don't have it exposed here, but it's something that we could do really quickly.
Got it. And so when you do the search, you're pulling back messages within a specific session. So you mentioned filtering, and that's important because you're not trying to peep into potentially what someone else is chatting with. Like that actually presents like a security concern potentially, right? And in some use cases, right, we can imagine that having a flexible or like wide open session would make sense. Like you actually might want to take advantage of like collective knowledge or collective information. But for this like conversational system, right, you're just searching over like yours. And when you get back those messages, like the user message, the assistant messages that are relevant to the question that you've just put in. So like, what was my favorite band? Just again, to make sure everyone's on the same page. It sounds like you're then taking that, and this is basically a form of RAG, right? You're putting that context you've pulled into the prompt for then the LLM to work with.
Exactly. Yeah, that's exactly right. And that is kind of like the term like long-term memory. That I feel like that's where it's being used. Like if you think of a user experience, imagine like you have some sort of application that you code with every day. It will be really good for that application to keep understanding what you're working on right now. But if I maybe ask a very specific question about something that I coded 2 weeks ago, that's where that challenge of retrieval and that long-term memory really comes into play. And that being said, like security and the privacy here is very important. A good way of thinking about this is you can definitely create multi-tenant indexes, so indexes that can serve multiple people with these filters. But you can also partition things differently, right? That's really cool because it's so flexible. You can partition by multiple indices, so each customer has a different index, or you can partition by databases. Each customer has a different database. So there's so many dimensions to that, and really it's flexible enough that you can take any approach.
Yeah, and I also want to hit on, like, actually, if you can bring up Redis Insight one more time. For those out there that are trying to build, I mean, this is a tool that's really helpful. You saw, as Sergio was demoing, like this gives you a look into actually the data layer itself, and you can actually debug things more quickly. And what I really like about this is you're like building your LLM application is that, well, first off, what you should notice right away is that within Redis, you're actually able to store a ton of different kinds of data, metadata, the sessions themselves, the indexed content that Sergio was showing us, and also even your token lengths. I can see you're using a string to keep that information. So it really is this like flexible, real-time, like Swiss Army knife of a database, which is perfect for these applications that need to be snappy, they need to be fast. And so, one of the things that I hear often discussed, in the community right now is like, hey, if you're looking for tools to pick to use an LLM and not to like blow smoke up, right? Like we're all here because we're talking about Redis, we're talking about Motorhead, but also like Sergio, from your perspective, can you talk a little bit about why did you guys choose a tool like Redis to accomplish this? Without putting any other, tool or ecosystem down, I'm just really curious, like why Redis, and what might be the advantages be here instead of picking something that's like a single point solution.
I think that's the answer is right there, right? The single point solutions are dangerous. I mean, I wouldn't say dangerous. I think that's not the right word, but you have to justify that decision. I think that's the better way to respond to that. Redis is very, like, we have a lot of experience with Redis. We use it for everything. It's like the thing that you always go to because it's reliable. It's fast. It's very simple, and it provides everything that you need. And so on top of that, for it to have vector search, I think it's awesome. Like even if we had a completely different product, we would 100% be using Redis, just because it's basically the standard for things like rate limiting, caching, even Redis streams now, which we also started using. So think about like a single tool that we use for 4 or 5 workflows, including one of our main ones, which is vector search. So yeah, I think it was kind of a no-brainer for us.
Got it. Yeah, we love to hear that.
Yes, definitely.
Yeah.
Couple of comments on Redis Insight. There's the ability to do the monitoring like you were doing on the Redis CLI. That's also built into Redis Insight. And it's also notebooks, which are like kind of Jupyter-like notebooks where you can basically do experimentation with different data types. Searching, all that stuff can be done inside of Redis Insight, and it's only getting better. I used to be basically always reach for the CLI, and now I'm using the CLI less and less and less. Especially once we start adding more visualizations of the data and things of that sort. I imagine that with the rise of AI, we would have a lot of more things that would basically help that whole observability part of the equation.
Awesome. Yeah, no, I use it a lot as well. I do jump back and forth, Redis CLI and this, but both are, I see them like both two separate things. This is more about like exploration. Like I wouldn't necessarily explore data in Redis CLI. I feel like I do more operations there. while here I can read data, I can look at how things are working. It's really cool.
So from like a 10,000-foot view, because I think we're kind of getting nearish the end of our time, and I'd love to like attempt to summarize what I think we've built, and then Sergio, you shoot me down if I'm wrong. I think what we've put together, what you walked us through, right, is this initial, we'll call it a clean slate. It was a chatbot where you could put in messages, you could get responses from a large language model like OpenAI's GPT 3.5 or GPT 4. And that's really kind of like the base case, because you can put in a message, right? You can type it in, it can respond, but it doesn't necessarily know anything about recent conversation history. It doesn't really know anything about past conversation history, or even like your domain specific data. And then you could see that because when you refresh it, right, like all of the messages went away. Like there was no state. These models don't have state. We talked about that at the beginning. So the first thing you did was you attached the Motorhead server, which allowed you to actually bring in the recent conversation history to be as part to be information, one that would load instead of our UI, so we could actually pick back up kind of where we left off. But then two was also useful so that again the model would understand kind of like a short-term memory window, like recognizing what you're talking about. And then we kind of did this additional step, which is on the Motorhead server, I believe there's a flag where you switch it to true or something, which basically now indexed all of these messages and as part of search, right, the long-term memory. And using Redis as a vector database, not only you're storing the messages, but you're storing the vector representations and making it searchable, so that when a user types in a question, you can look inside the vector database to find what are the most relevant pieces of this conversation going back potentially really long, right? Like you could have an index that has hundreds of thousands of conversational records that go back weeks or months or years. And then it fetches that and brings it in as context as well, so that the model can actually reason with things from the past and reason with things that you've talked about previously. And so that kind of, I think, is where we are now, right? Which is we have the session and we have long-term and short-term memory. All this is powered by Redis, and it's also powered by the Motorhead server that you've been working with.
A follow-up question. Oh, sorry, go ahead.
No, I was just gonna say that's a great breakup of what we just did, and like you could build these pieces however you want. Like it's not a like in this case we were just doing like this basic like long-term memory, but this thing can be as complex as you need. You can like how you were mentioning that you could have filters around only fetching the user messages, only the assistant messages. You can even have different data sources, and that's where a lot of the application work comes into play, where let's say you have something that decides where to query first. An interesting problem that to explain what I'm talking about is asking the LLM something about something that I talked about the previous message. So if you say like, tell me more about this, and I just take that and query our vector, it might not be the best approach. So that's where a lot of really intelligent or I would say like really good ways of abstracting that and creating like reasoning and where we have to query something versus another thing is also really important.
That's kind of what I wanted to ask you. In general, if somebody's using Metal and Motorhead, do you expect them to be saving in terms of API calls to, let's say, a paid service like OpenAI's?
That's interesting. So I think that it really depends on the use case. We don't necessarily are looking to improve that metric. We're not saying with us you will call less APIs or even make things make things necessarily cheaper, but we focus on making things better and have the better results possible, obviously within reason. And we are obsessed with performance. So kind of like that intersection will always take us to not making those calls when they're not necessary. But sometimes it's necessary to make several calls if you're building like a really, really complicated reasoning. Sometimes there's no way around it. And yeah, that would be my answer. Not easy to answer.
Thank you.
And Sergio, we had a question from one of the users in our chat. Just trying to also flush out like some of the best practices to make sure that your data is updated. So I'm assuming we're talking about like the context, but like what are some best practices you've seen, and how do you guys think about making sure that your vector index as well as other metadata are updated, and that the LLM is getting access to the most like freshest content?
Yeah, this is where a lot of Metal really shines. We've been working with, like I said in the past, with CRM data, and CRMs are really interesting because you receive data from a lot of places, and everything is live, and everything has to be searchable, everything has to be discoverable. You have to be able to filter by anything. You need to run reports, and so like that mindset that we come from really taught us to focus on making things live, snappy, performant, searchable. And so a lot of the best practices here is just to make sure you have a source of truth. I would say like this is just like some engineering ideas that come to mind, but have a basic source of truth, have some sort of events or systematic way of updating everything that is related to the record that you just updated. So let's say you have a file, right? You have a document like a PDF, and you create embeddings from that file. Make sure if you update that file, that ID is stamped everywhere, so you can kind of like with an external ID, sometimes it's called, or a foreign key, or however you want to call it, you update everything else. And so in order to have those flows, you need to have an architecture that allows for that. And a message system would be generally good for that. And so generating events, handling those events in a worker, figuring out where all the data sources are, all the indexes, and updating those. But it's a really hard question to answer. It really comes down to whatever you're building. At Metal, we basically do this. This is our bread and butter. Yeah, it's really about like architecture and managing events and making sure things are eventually working, retries, and so on.
Yeah, that's awesome. I think it's a really hard problem, like data syncing, data movement, data syncing. I often get asked like, hey, we have our like enterprise knowledge base stored across like SharePoint and like some files on someone's computer in a Notion, database or drive, in a Google Drive. There's like all these different sources, and trying to be able to sync with all of them is a hard problem, legitimately. But I think it's an area that there's going to continue to be probably more innovation in the space. It's like we started with the fun thing, and now we get to go back and figure out how to do ETL properly at scale for all of these systems.
Yeah, that problem is really hard for things like I feel like for things like documents is simpler because you kind of know, like you have some sort of like a hash zip, or you have like a hash in a way you can know the state has changed. Sometimes for a website, it could be more complicated if there's dynamic things. So the website might not have changed, but the content did somehow. Like the code stayed the same, or vice versa. And so if you look at the website, you need to figure out a way of generating an identifier for that. And then let's say you add like chunking to the mix and you change a paragraph with it, like in between two chunks. You have to recalculate all the chunks, you know? So there's a lot of problems there. A lot is still has to be solved. Yeah, it's very interesting area.
Definitely. Well, Brian, do you have any other questions you want to jump in on? Otherwise, we can talk about some use cases.
One quick one. What do you foresee in the future for the product? Where do you think you want to take it, or where do you think it might be going in general because of the industry movement?
So I think the first thing is to incorporate into open source models. I think that is very important. For example, we're using here APIs, and a lot of it has to do with the fact that they're very simple to use. And but now with being able to run like very small models locally, I think it's really cool what's happening with all of that like quantization movement. And like optimizations to run it in a MacBook. I think it's really cool. So having a way of handling different models for Motorhead, I think would be really awesome. Different embedding models as well. Easier ways to deploy this. I think it's something that I'm really interested in. And then like a lot of what Tyler said, like diving deeper into retrieval, I think would be really cool. That's for Motorhead in general. For Metal, I feel like we're growing so much. We're learning so much with working with our customers. We are investing a lot of work into improving the retrieval itself, and we feel like vector search is really powerful, but it's kind of like one aspect of it. We need keyword search, which we know that Redis search provides as well. And then beyond that, we want to be able to connect to any type of data store that you have. So imagine like an SQL database, imagine like a MongoDB database with indexes, and kind of figure out ways of how to talk to all of those data stores to respond to any question that you have. That is like our vision. Like you ask us something and we will respond to you with a high degree of probability, a high degree of accuracy with sources. That is kind of where we're moving towards.
Very nice. Can't wait to see how things evolve.
Awesome. Well, maybe the way we can kind of wrap this session is we can discuss a little bit about some of the practical, like real world use cases we've seen. And if we can, let's see if we can actually pull up the little diagram here. Perfect. Okay, so we kind of identified 3 areas when we were chatting about this before. There's plenty more, right? This is quite ubiquitous technology, but the 3 sectors we've spent the most time in seem to be really financial services, customer support, which is more horizontal because it can cover a ton of different areas, right? And then marketing and PR, also another like sort of horizontal thing, because almost every organization out there has content, they have historical content, and they have user bases, they have user profiles and descriptions, and they can use that with generative AI and large language models to try to like create more unique copy that speaks to a particular audience, and of course with humans in the loop to refine and to like customize even further. But anyways, that I just wanted to kind of bring these up and see if you guys had any insight or anything you wanted to jump in with in terms of some industry use cases out there.
Yeah, absolutely. So I feel like financial services has been one of our major focuses. Is there's a lot of opportunity for improving how can analysts discover and analyze and reason with data. A lot of the time is really for a lot of these people is really just looking for the things that they want to read and discern, right? A lot of times, like, going through all of this data takes just as much time as the actual work that they're doing. And so we see a lot of potential for improving that workflow, for helping them discover that data more quickly and kind of resolve a lot of the blank page problem. We do not think that it's going to replace in any way something like analyst 100%. That's definitely not going to happen anytime soon, but it's going to make them so much more powerful, just making them find the information faster, verify the data. I think that's really interesting, and we're seeing a lot of pull towards that.
Yeah, definitely. And I can concur with that one. You know, Redis as a technology is widely adopted in the financial ecosystem. There's a variety of reasons for that. But with the generative AI and large language model push, we've definitely seen a couple use cases around like knowledge assistants that are aware of like internal processes. Like one example is like with a wealth management team, they're trying to create this conversational bot that will help their agents actually make the best decisions and reason through, like you said, some of the latest market trends data, some of the particular customers that they work with, their risk tolerance information, like just a ton of like personal information to help speed up their decision-making process, increase their velocity, like you mentioned, and ultimately generate more returns for them as a business. So I would say that one, and also kind of just more generic customer support, which typically starts out as this like internal use case where it's like not a like public facing chatbot yet, but I see a couple companies that are looking at, let's build this like chat with our documentation, chat with our knowledge base, to learn more kind of experiences that they intend to one day kind of flip the switch and actually put it public facing so that it becomes a community and customer driven tool. So those are the two areas that I see a ton of traction in so far.
Yeah, and for marketing and PR, what we've noticed is that it drastically helps people find that information faster. A lot of those businesses are, a lot of the businesses that we talk to and work with have years of historical data, and could be like, imagine presentations made to X company or campaigns then made for Y startup. So they keep growing this massive amount of decks and documents and data, and now they receive a query about creating a new project, and they want to see what has worked and what hasn't, or for example, they want to understand a new creative, like generate a new creative experience for someone. Then you could use something like LLMs to really improve your workflow, and especially combined with Retrieval and Metal.
Nice. We do have actually one more question I think might be a nice softball for us, and maybe Brian, you can take this one, which are like, are there scenarios or ways to update Redis, the index in Redis, like once it's created for this unstructured data, like, you know, marketing data?
Yeah, I mean, the index maintenance, it's regardless of the platform, is always a tricky proposition. Redis itself uses a background thread to basically index the data on change. So the moment that it basically a change hits the disk, we start reindexing. I can see, for example, if you have, let's say, a data set of images or something like that, and you're vectorizing that and creating embeddings for them, putting them in Redis. having maybe a SHA of some sort, some kind of hash, to basically keep an extra level of basically detection of mutability of the data that could be very fast, might be a way to do it, and basically do, rather than allowed the indexing to happen by itself, you might be able to stage it, to have, for example, a set of hashes that has the prior data, and a set of hashes that now has the mutated data, where you can basically kind of stage the indexing so it doesn't happen in the middle of an operation. So yeah, there's a lot of patterns in Redis to kind of do this hot swap in cold swap approaches. So yeah, I mean, the Redis search, it's very powerful, but you probably want to manage to the scope of your searches, like Sergio was saying, having indexes perhaps per session or per user, rather than having one big index, in maybe filtering the whole search using just a prefix. So how you chunk that, it's very flexible in Redis. So I think your use case will dictate that. But yeah, there's a lot of different ways. But I'm a big fan of basically hashing documents in any large chunk of data, so you can then make a decision. Some things might be might be old school on a 24-hour cycle, where you basically say, here are all the changes that we had, and now we rebuild the index. Or we, it might entail even manipulating some of the long-term memory that something like Metal keeps in at hand. So I think that's what Sergio was saying about basically when there's a change propagated everywhere. That long-term memory might be one of those places that you have to propagate that change.
Yeah. And I think the key thing is, like, with the APIs that Redis provides, like when you're building, like as you make updates, like if you make the decision to update data, which again, that's a whole like code, like a complicated topic, right? But if you make the decision to update data in Redis, like you can be pretty certain that when you make like an hset or a JSON.set command to like actually write those updates, the upserts, that data is going to be properly re-indexed and reflected in Redis in like near real time. It's not perfect real time, but it's near real time, and that's something we're certainly like pretty proud of at Redis in terms of its performance. And so yeah, it's a powerful tool, and there's a ton of ways you can leverage it for LLMs. And I think that the story here with Metal and kind of being able to build together today, like we saw, is really just the tip of the iceberg. I think there's a ton more possible. And so, unless there are any other like questions or discussion topics we want to hit on, we've been going for over 2 hours. It's crazy how time flies by.
But you're having fun.
Yes, exactly.
Well, I mean, I really want to say thank you to Sergio for sharing some of the insights, the journey, and actually for bringing the product to the forefront, because I know there's a lot of people that are starting to play with LLMs, in having a jump off point that would basically, like Metal promotes, basically bringing AI to the enterprise. It can take a long time if you are just getting started. So I think something like Motorhead can really accelerate that.
Yeah, no, thank you to Redis. Thank you so much, Ryan, Tyler. It was a pleasure. I hope the coding was fun. It was really fun for me.
Absolutely. It was great. It was a great session, and obviously, this will be some format of this will be available for folks to kind of chime back in and rewatch. And all the links that you've seen, right, are in the comments on YouTube, and there's our YouTube channel link right there where you'll be able to dive back in once this posts. But yeah, thanks everyone for tuning in on a Friday. Hope everyone has a great and safe, fun weekend with your LLM as you try to build a chatbot. But yeah, thanks everyone for being here, and have a great weekend.
Thank you, guys.
Thank you. See ya.